Hello, my name is John Cowart. I'm an instructor here at Lincoln Tech in Grand Prairie, Texas. I want to go over a little bit of how to check for superheat, subcool, de-superheat, and a compression ratio. Also, how to hook up the gauges and interpret what you're actually seeing. So first thing, we've got our little system here. We've got our compressor. We've got our condenser with fan. We've got our evaporator with fan. And on this side, you can't see it, but there's your metering device right here. We also have a sight glass, liquid line filter dryer. So let's talk a little bit about the lines. Right here we have our suction line. That's the one that's going to be insulated. Mostly on residential units, you'll see that the suction line is only insulated. On supermarket refrigeration, they insulate both lines. So we got our suction line. Our suction line goes all the way up to the evaporator. We also got our suction line comes back from the evaporator, comes back around, goes through here, goes back into our compressor. Our discharge line here, which is going to be the hottest line on the unit, goes right here and discharges into the condenser. The liquid line will come out over here, come out and go up through our filter dryer, through our sight glass, and through our metering device before it goes into the evaporator. So let's go ahead and hook up to this system. First of all, I want to take these off. These should be tight enough where you have to use a crescent wrench to take them off. I've already loosened them up. Go ahead and take those off. Right here you have your king valve on this side and your suction side service valve. These are three-way valves. When the stem is all the way up, the valve is closed. That is called back-seated. When the stem is all the way down or in, that's what we call front-seated. And anything in between is going to be your mid-seat. So let's go ahead and hook up. So I'm going to make sure my gate valves are closed on either side. I have my compound gauge and I have my high pressure gauge. Let's go ahead, hook up here. Check, see, this is in the back-seated position. I don't see anything or feel any pressure or hear a hiss. So I think it's safe we can go ahead and take that off. Go ahead and hook this one up. Now let's go ahead and hook up our suction side. Same thing, I want to be careful when I'm taking this off. If I hear any kind of hiss or feel pressure or see refrigerant, I need to make sure that this stem is seated well. Let's go ahead and put that on there. Now these hoses we're using are your standard hose, but they do have low loss fittings on them. Low loss fitting I will show you before I go any further. On this line, your low loss fitting looks like this, and you can close and open that line with this. These are very good to have when they're already built in like this. This is a ball valve on here, so it really doesn't go bad that easy. So a little bit different. These are, I would say, manual instead of an automatic. You can get automatic ones which open and close for you. Alright, so let's go ahead and see what we're going to go on. Let's go ahead and hook up. Let's make sure everything is tight. You don't want it over tight, you just want it snug. Let's go ahead and pop this open. I'm going to put it in the mid-seated position. I'm in the mid-seated position and I've got pressure on my high side right now. So what I'm going to do right now is I'm going to go ahead and purge it before I go any further. That's all I need. I want to purge the air out of that line. Two things we want inside the system. We want refrigerant and we want oil. We do not want any air. Air is a non-condensable and can cause our pressures to get out of kilter when working on things. So you do not want air in the system. So it's vital that you purge. I'm going to open this one up. Now I can see my low side pressure. I'm going to go ahead and purge this. Like that. Now I want to purge this yellow line. So what I'm going to do is I'm going to open this up for a split second. Get a little bit of refrigerant inside here. That's all I need right there. That's all I need. I just need a quick, that is called a de minimis amount. We want to make sure we have no air in the system. So let's look at what we got right here. I'm showing on my gauges right here, we've got about 28 PSIG, and we're about, I'd say 124 on this one. So what we can do is we can take those numbers. What you like to do is you want to write them down what you've got. So we've said we've got about 124 on the high side. So 124 PSIG. And we're running probably around 28 on the low side. Now what I want to do is I want to change those pressures to a temperature. So what I'm going to do here is I'm going to go to my PT chart. I like to use the Danfoss refrigerant slider. It's pretty accurate and it seems to work really, really well. Alright, refrigerant that I'm using on this. If I look here, it says I'm using R134A. So I'm going to go with that. Always important to know what refrigerant you're dealing with so you can get the proper temperatures. So let's go to 134A. 134A is a solid compound, so you don't have to worry about the dew and bubble point like you do with the 400 series. So let's see what we got. We got 28 PSI. We'll do the low first. That's going to give me an SRT low of 32.27. 32.27 degrees Fahrenheit. Now let's do the high side. High side we said was, well, let's look, it's dropping a little bit. I'm going to say we're more or less 120 now. So let's do that. And that gives me 98 on an SRT high, 98 degrees. So at those pressures, that is what the temperature is. Pressure-temperature relationship. Now we'll look here, and also on these gauges, this actually has on these inner part, these are temperatures. The outer part's your pressure. Now, at a glance, you can see what your SRT low and high is by looking on that. So if I look here, my SRT low, 134A, is the inner blue ring right there. That's going to be about 32 degrees. SRT high is going to be really close to what I said it was. It's going to be about 98, because I'm under 100 right there. So you can see it at a glance. Some gauges have the refrigerant on it that you're using, some do not. But all of them will have pressure out there. And with that pressure, you can always find out with the PT chart what you're working on. So let's go ahead. Let's let it run for a minute. Now I noticed we said my coil, this coil, is about 32 degrees. Well, this is refrigeration. Refrigeration is cold. If it's getting cold, it's pulling air across it, cooling the air. Right now, this doesn't really have a space it's trying to cool. This is more of a trainer. So 32 degrees is freezing. So if I keep this at 32 degrees like this, I have a possibility of freezing up my coil. So I may need to add a little bit of refrigerant here and there. We're just going to let it run and see what happens. I do not have a full sight glass. Usually that is a telltale sign that you don't have as much charge as you need. On this situation though, on this application, because I'm not actually cooling a space, it's just running for training, then I'm going to bubble the sight glass a lot, because this is trying to cool this whole room and it's not designed to do that. So let's see what we got here. Let's go ahead and get our meter out. Let's go to Fahrenheit, Celsius. And let's go ahead and plug in our temp probe. This is the temp probe that you get with your tool kit. K-type thermocouple. It's only really one way this thing goes in here. And let's go ahead and get some temperatures on our lines. Let's go ahead and do our discharge line first. So I'm going to clamp that on right like that, and we're going to give it just a minute to see. We'll go ahead and try to stick that right there. We want to give it a second to see where our temperature is and how it's going. Right now we've shot up to about 124 degrees. Still going. I want to make sure I let it settle down first. About 126 we're going to call for a DLT. So that's our discharge line temperature. Alright. So let's go ahead and put on our liquid line. Let's get a liquid line temperature. Always let the system run when you first turn it on too. You can't just get a subcool and superheat reading just when you first turn the system on. You need to let it come down and let it satisfy and get where it's about needs to be for its design. This right here is going to be out of design because we use this just for training measures. But we can get an approximation of what we need to get. So our liquid line temperature is 92 degrees. Okay? Suction line temperature is another thing I need. Go ahead over here to my suction line. Let's see. Pull this back just a tad. Get on that suction line right there. Always want to make sure you've got a good connection with your temp probe. Give it a minute and come on down. Always let it run. So the temperature continues to drop. I can feel some heat being rejected here because heat would be absorbed here, heat would be rejected here. Now in a real scenario, this would be away from the evaporator because you don't want the heat that gets rejected right here to go right back up and be absorbed there. You want this heat rejected to a place where it makes little or no difference. Alright, we slowed down to about a 75 degrees on our liquid line. So now that we have all our variables, we can kind of see where our superheat, subcool, and desuperheat are. So with doing just a little math, I can find out what my superheat is. That's pretty much kind of what the heat I'm absorbing here into the evaporator. So I'm going to do suction line temperature minus SRT low. So suction line temperature we said was 75 degrees. Pretty warm. SRT low we said was 32 degrees, 0.27. Want to subtract those two. So 75 degrees minus 32.27 will give us a superheat of 42.73 degrees. So my superheat, 42.73. Now that's really high. Really high because normal superheat nodule in a system would be probably 8 to 12. Right now, because I'm trying to cool this room with this trainer, I'm picking up a lot of superheat. So that's why it's off. Let's check our subcooling. Subcooling is going to be SRT high minus liquid line temperature. SRT high was 98. Liquid line temperature was 92. Minus 92, 6 degrees. Most subcooling you're going to have for systems with a TXV, which is a type of metering device, is going to be between 10 and 15. Like I said, we're out of specs with this trainer because this is basically just to train you on how to hook up and get basic measurements. When you get out into the field, you'll be able to see stuff that is either in a nominal or out of range. Right now this would be out of range, so as you know this would have a problem. Let's check out desuperheat. So discharge line temperature plus 50, DLT plus 50, minus SRT high. Our discharge line temperature was 126, 126 plus 50, that's going to be 176, minus the SRT high, which was 98. Going to give us 78 degrees. So what is desuperheating? Desuperheating mainly means as soon as I come out of this discharge line, excuse me, I'm going to immediately start to desuperheat. That means the temperature is going to go down along the line. As I get into the coil right before I'm changing state, we want to drop that temperature as low as we can on that line so it gets close to condensing temperature. So condenser does three things. It desuperheats, it condenses, changes state from a vapor to a liquid, and it subcools. So I'm losing about 78 degrees from this point to where I start to really change state. So that's how much heat I'm losing. Last but not least, let's check how this compressor is doing. Let's see what the compression ratio would be. Simple equation to do this. We're running about, let's check our pressures again to see if we've changed a little bit. So that's 25, 30, let's see. Let's say about 27 psi plus 15. What do we got on this side? We're still running about 120. So that's going to be 120 plus 15. So that's going to be 135. 27 plus 15. 42. Now let's divide those two numbers together. So this compressor right now has a 3.2:1 compression ratio. Now when we get into compressors later on, I'll explain more of what the compression ratio is, but it allows us to kind of see how hard the compressor is working or how hard it's not working, to make sense on that. That'll be a later thing we'll get into at a later day. So go ahead and get ready to dismount this system. What we're going to do, this is how we get the liquid out of our gauges. Now then, you can use your low loss fittings on this, but low loss is mainly, I think, for Schrader valves. Schrader valves is something we'll deal with in a later video. So what I want to do first, I want to back seat this valve. So I'm going to back seat it. The stem's going to be all the way up, just like that. I'm going to open my high side gauge. Now what I want to do is I want to flash in the liquid, because I've got liquid all the way up to here and some liquid in there. I don't want any liquid in my gauges. I want it just to be vapor. So I'm going to flash it out. Once, twice, 3 times. I'm just going to leave it open. Now what's going to do is these pressures are going to equalize with each other. So I'm actually putting the refrigerant back in the system instead of taking it off on my hose and just wasting it. We'll let it roll for just a minute. You look here, we're about a 40 and we're about a 40 there. So our pressures have equalized. So I can go ahead and turn this off. But I'm going to slowly undo this one here. No liquid. I'm going to go ahead and put my hose back up to my blind port on the back. Blind port just means it's a place you can screw your hose on that doesn't go into the gauge itself. Now I want to go ahead and backseat this valve. Go ahead and close over here. Just take this off slowly. If you hear a little hiss, that's just the vapor inside. There we go. Take those off. Close everything down. Now for this system, I want to make sure, I want to put back on these. If it's going to leak, it's going to leak around these points. It shouldn't leak if it's a brand new system, but the more you play with these valves, in the field, they probably only get maybe once a year somebody mess with them. Here, this is on a daily basis. So they tend to wear out faster. So I want to put my caps back on. It's going to keep my refrigerant from leaking out if it does decide to leak there. I'm going to put these back on for my stems, because I want to keep my stems nice. Out in the weather and stuff, they get cracked, dried out. And I just want to give this just a little bit of a snug. I want to do that so I can't just take these off with my fingers. I like to do it that way I know it's extra together. So things we used for this, we used our gauge set, we used our refrigeration wrench, we used a crescent wrench, our meter, our temp probe, of course a PT chart and a calculator. Some of this you can calculate in your head, but I just prefer to use the calculator to be double sure. I'm going to go ahead and turn this unit off right now because it's not really made to run all the time. I'm going to turn that off, turn that off. Thank you so much. I'll see you again.